Hey everyone, this is Mr. Kramer. I'm just recording a short video to show you how to get into the molecular shape project. So you'll find it on the home screen if you go down to the week 5. It's actually hidden inside the 7.7, 7.8 practice assignment. So if you click on that and you load up the CAMI assignment, you will see the practice assignment that we worked in class on Thursday and Friday. But if you scroll down to the 6th page, you'll see that it starts the molecular model project intro. So what I want to show you is how to do this stage of the project. It should be pretty quick, but it should also be finished by Wednesday night. So here we go. I have a long list of possible chemicals that you could pick. In class, I went through a couple of these examples, but they're really broad. Some of them are like nutrients, so like any of the vitamins, vitamin A, B, C, D, you could take. Some of the things that we eat, like sugar from your table or from a fruit, or maybe even like fake sugar. If you want to look at proteins, then you could look up one of the 20 different amino acids as a possible choice. If you're interested in chemicals that we use as like drugs, there's stuff like Tylenol, which is technically acetaminophen, or Advil, which is technically ibuprofen, or if you have any other drug you're interested in, you could look that up. I've also included some illicit drugs like cocaine or THC, if that really gets you going. There's also a whole class of hormones you could look at. So I picked testosterone as an example, but also estrogen or cortisol, which is the stress hormone, or any of these are totally acceptable. So there's a wide range of possible choices of chemicals you could pick. So what you should do is pick one that seems interesting to you. Let's assume you picked serotonin. And then you're going to do some basic background research. So when was the chemical first discovered and made, and probably who discovered it, and where it was discovered, etc., how it was discovered. What purpose does the chemical have? So what is it now used for today, or maybe how was it used in the past? And then finally, what is the chemical formula? So a lot of this information you should be able to find from a website like Wikipedia, especially the chemical formula will be there. So if I look up serotonin on Wikipedia, I can see a picture of what it might look like, a lot of information about it, because this is a chemical that's found naturally in the body, and so as a result, there's a lot of research that's been done on it. But if I scroll down here on the right side here, at some point it'll get into some properties, and one of those will include the chemical formula. So I could copy that into my document if I wanted to. If I wanted to look at the history of it, normally there is a history section on Wikipedia for something. So here there's some history about this chemist Vittorio or Spalmer or something, who first discovered this or isolated this chemical in 1935. And then as for its uses, sometimes Wikipedia can be very dense when it comes to that, and so it might be more useful to find like a science communication article or something like that. So like, what is serotonin, and find a more sort of generic article about it. So here's serotonin syndrome, which has to do with having a low amount of serotonin, which could be interesting, but maybe more accurately just find an article that explains kind of what it does. So what does it do in the brain, in the body? What does it regulate? Mood, digestion, etc. So you could look up, read this article, and then synthesize that into a couple of sentences here. And then last is the chemical formula, which of course you can just rip from Wikipedia. So by chemical formula, I mean really the chemical formula, not the picture of the structure. I mean this piece of information right here. So this tells us that in the structure there should be 10 carbons, 12 hydrogens, 2 nitrogens, and 1 oxygen. So that information will perhaps come in handy later. So I'm going to just copy that in here. And then next, I'm going to show off MolView. So this is a website that we've used in class a decent amount, and you are now going to have your own turn to use it. So let's start by practicing by trying to draw a picture of water on this website. So I'm going to click this link, which will open up MolView. And it starts with some weird structure in here. So if you hit the little trash can, that will delete what is on the screen. And then we are going to try to draw water. So water has an oxygen atom. So the atoms are over here. That's oxygen. And it has 2 hydrogen atoms. So hydrogen is right there. I can use the mouse wheel to zoom in, and I can place those on opposite sides. And then when it comes to making a bond, then there's some bonds over in this direction. We just want a single bond, so I'm going to pick the one in the top left. I'm going to click and drag to connect them. You'll see that kind of a random carbon shows up, and we'll get to why that is later, but just connect the 2 dots and we have our structure there. So now if I want to see this in 3 dimensions, I hit this 2D to 3D button. And so that will translate my drawing into a 3-dimensional image. And so we can see this is H2O, and it doesn't look like an H and an O and an H in a straight line, but rather it has this bent shape. And so we've been learning a bit about molecular shape, and here's a good example of that. Something to note is that the lone pairs that should be on this won't be there. So whereas there should be 2 pairs of dots on oxygen, those won't be present on this website, but they're still accounted for clearly, because otherwise we wouldn't end up with this bent shape. So the website is kind of smart when it comes to translating these drawings into structures. Now, if there's some really bad mistakes in your drawing, it might not know what to do. For example, if you have like hydrogens bonded to each other and then you try to put this in there, it will bond these hydrogens together even though they wouldn't be able to do this. So there are some problems. It doesn't check to make sure that your answer is correct. It just kind of connects some stuff and sees what happens. Okay, so we have water. Let's go back to the correct drawing. And the next thing is we want to work on something a little more complicated. So we're going to build this molecule here, and the way to do that, or the best way to do that, is to kind of like have both windows open at once. So I'm going to kind of drag this so that you can see the subject and then also the canvas, if we're talking like art terms. So I want to put a carbon. I'm going to start sort of on one side and work my way through the molecule. So I'm going to put a carbon here. I'm going to zoom in a bit. And I'm going to put hydrogens, 3 of them, bonded to this carbon with single bonds. And then I'm going to make another single bond here to another carbon. So I'm going to put a carbon and a single bond. So I'm kind of copying what I'm seeing in this drawing. Don't worry too much about the angles you put your bonds in, because this will kind of automatically fix that after it converts it into a 3D drawing. So the next, I have a double bond here, so I'm going to put a double bond, and it will default to picking carbon as the atom to bond to if you don't tell it otherwise. So what I can do is I can just click the oxygen atom button here and replace this carbon with an oxygen. I can do that to all of these atoms, but that's not what I want, so you can just replace the one I'm looking for. Next, this will bond to another oxygen, and then to a hydrogen. So I can do the same thing where I replace that. And here I have my structure as it matches there. Notice there's no lone pairs on here, but when I hit 2D to 3D, I should get the shape that I'm backwards here. I should get the shape that I drew vaguely in this shape. And so it should match up with the drawing that we have on here. This was just kind of a check to make sure that you were able to do it correctly. So we have the same looking thing. I think it's reversed, but it's the same image. So we're in good shape. The next thing to do is to label the geometries. So I'm not going to go into how to identify those geometries, because this video would get too long, but basically you should be labeling each of these centers. So the central atoms, this one has 2 bonds, this one has 3, this one has 4. So they all count as central atoms because they're bonding to at least one atom, or at least 2 atoms. So this is going to be in a bent shape, which we could see because of the, we can see in the 3D model that this is a bent shape. This is going to be a triangle plane. So it's in a triangle shape because there's 3 bonds, and it's flat, so it's trigonal planar. And then this is a 4 bond center, this carbon here. And so 4 bonds is always going to be tetrahedral. So bent, this is going to be tetrahedral. and this is going to be trigonal planar. Okay, so this is basically the process that we're going to go through for your project. I'm going to do one more example, or at least the first half of another example, with benzene here. So actually, this isn't benzene. This is a chemical related to benzene. So I'm going to do the same thing. I'm going to try to draw this chemical using the MoldView website. So I'm going to open that up again. I'm going to use the trash can to get rid of the drawing I had. I'm going to go through here. There's actually a trick. If you see these these rings, and you see these shapes here, I can make a ring show up automatically of carbons by using that, and that can speed up this process quite a bit. So I can make a ring of a hexagon of carbons, and if I want to, then I can put double bonds everywhere there's supposed to be a double bond, and then I can attach hydrogens all around it. Got to drag this into the correct place. And then on the top, instead of a hydrogen, there's an oxygen. So I'll put that there, and then a hydrogen off to the side like that. So the ring can really speed up things, especially for some of the larger chemicals, which are very large. So now we're going to want to do the 2D to 3D thing again, and so we can now see our two-dimensional, or a three-dimensional, that is, version of benzene. And so you can see that this is all flat, and it kind of looks like a snowflake with a little Rudolph head on the top. Makes me think of Christmas. And so if you wanted to download this image, which you're going to have to do, there is a function on this website to make that happen. So if I want to paste this 3D image into my document, I'll kind of get it set up so it looks nice. And then I go to this button here where it says Tools. I click that and go down to 3D Model Image. So I click that. And then I will name this, so I'll say that this is my snowflake. Snowflake. And if I open that document, it looks like an image of what I did. If I bend this so it's like weird and you can't see anything, then it will save it in that configuration as well. So if I say this is a bad snowflake, and I look at it, it will look garbage. I can't see anything, so this is not a good configuration. So you want to make sure that it is lined up as you want it before you save it. And then I can go into my document here and paste it. So the way to do that is to use the Add Media function. So I click Add Media, and if you saved it to your computer, you can use My Computer. If you saved it to your Google Drive, because you're on a Chromebook, you can use Google Drive. I saved it to my desktop, so I'm going to go through here and look for Snowflake. That was what it was. So, and I can just paste it right into my document like that. So what you would do is you would go through and label all of the centers. So again, all of the atoms that have at least 2 bonds. So that would be this chemical. This chemical is making 3 bonds, 3 bonds, 3 bonds, 3 bonds, 3 bonds, 3 bonds. And then you go through and label it. So I'm going to do one more example based on the serotonin chemical that I picked. If you feel like you're good to go, then you can stop the video now. Otherwise, I'm going to do one more example just in case you're interested. And then if you have other questions, please find me on this upcoming Wednesday. So that would be March, what day would that be? March 10th. So I'll have my Zoom room open on the 10th, even though we don't have school that day, in case you have questions about the project. Okay, so you may need to add another page to your document in order to fit everything in there, but for now I'm just going to use this page here. So I'm going to look up serotonin on Wikipedia, and I'm going to use this structure here as my subject, and then I am going to use MoldView to copy in this structure. So there's a couple of tricks here. First of all, you'll notice that there's a lot of missing atoms. It's not listing what's going on with this hexagon, and it just looks like a bunch of like angles, like kind of like a honeycomb with some sticks sticking out of it. So notably, if I leave this toggle unclicked, then when I put in this hexagon, it will look just like their hexagon does. You see how those are very similar. So the problem is that right now it's not showing any of the carbons or the hydrogens. So everywhere where there's kind of an angle here, there's secretly a carbon atom that is in that location. So if I click this button, it will actually show that. So all of those angles are secretly carbon atoms hiding away. And then by default, in this kind of ring structure with the double bonds, each of these carbons will be bonded to a hydrogen as well. So there's our hydrogens hiding all over this ring as well. So it can be a bit complicated if you get a collapsed or skeleton structure that doesn't show any of the carbons. But you can see why it's appealing, because this kind of looks nice, whereas this is a bit clunky. But for your own drawing, you're going to want to go into as much detail as possible. So I'm going to kind of start with this ring and start adding things to it. So this carbon isn't bonded to a hydrogen, but rather to an oxygen. Actually, it might be easier to start without these hydrogens here. So just like this. And then that O is bonded to an H. So this OH here is not a new element or something. This is just a shortcut for showing O, then an H bonded to it. They just didn't have space to draw the bond, but we do. All right, next we want to make a pentagon kind of on the other side of this. So we're going to draw a bond like this, a bond like this, a bond like this, and a bond like this. Kind of looks a bit warped, but it'll do for now. It looks like there's a double bond in this location here, so I'm going to put that there. This carbon isn't supposed to be a carbon, but is rather an N. And so, and that N is bonded to an H. And then over in the top corner, we have this kind of wiggly line. Remember that each of these angles are really carbons. So that's one bond to a carbon, and then a bond to N. So bond to a carbon, then bond to a N. And this N has two H's on it. So I'm just kind of following the, I moved kind of from left to right on the structure. And then the last thing I need to do is add hydrogens for all of the carbons until they have a total of 4 bonds. So what do I mean by that? Well, this carbon is making 4 bonds already. This carbon is only making 3 bonds, so it needs to stick another hydrogen there. This carbon is making 3 bonds, so I need an extra hydrogen. This carbon's already making 4. This carbon's already making 4. This carbon's making 3, so I'm going to put a hydrogen. This carbon's making 3. This carbon's making 4. This carbon's making just 2, so I need to add 2 more hydrogens. And this carbon's making just 2 bonds, and so I need 2 more hydrogens. So I zoom out a bit, and this is my structure for serotonin. So what I'm going to do is I'm going to copy this structure into my document as well. So I'm going to go to the Tools tab and download the structural formula image. So I'll call this serotonin structure. So I'll save that. And then I'm going to hit the 2D to 3D button, and indeed my structure pops up. It's rotated a bit from how I drew it, but you can see that this ring area over here is kind of flat, and then there's this kind of branching path up there that ends in a nitrogen. There's an N inside the ring, just like I have it drawn, and then this OH sticking on the other side. So this is kind of what I want. Maybe I'll angle it a bit so I can see all the atoms, and I'm going to also download the 3D model image. I'm going to name that serotonin model. And then I'm going to go over to my assignment here. I'm going to paste in both images. So from my computer, I want the serotonin structure, which looks like this. I can maybe blow it up a little bit. And then I also want to add media from my computer, the serotonin model, which looks like this. Put that in there, maybe blow it up so I can see it. And then I would go through and I would label all of the centers on this molecule. So that's basically it. If you have other questions, find me on that Wednesday, and I'll do my best to help you out. Thanks.